Hello, my name is Kenneth Anderson, and I am with The Ohio State University. A little bit of background on this project. We won a USDA grant in 2011 for around $80,000 to conduct a 2-year study to evaluate the use of microclover to reduce production costs on sod farms. This is done in partnership with Dave Gardner, Debbie Holdren, and John Street. To start off with, what is microclover? It's very similar to common white clover, Trifolium repens, that's found in home lawns. What's different is that it's been selectively bred for specific characteristics. The picture on the left, you can see a man holding 2 different sizes of clover. Microclover is much smaller when it's integrated with turf. If you grow it up separately, it's going to get larger leaf sizes because there's less competition. But when it's integrated with grass and mowed, it's definitely smaller. What's also important is that there's less clumping and it integrates better with turf. Many stands of clover are large and monolithic, but with microclover it integrates, as you can see on the right hand picture, that it integrates into the turf, sharing the same space. What's also important is that there's less flowering. As you can see in the picture on the right, the dime is showing representative of the size and showing how small in correlation that the microclover is. As we mentioned earlier, we are evaluating how to reduce production costs of sod farms. So now we get into the how. So to start off with, reduced fertilizer inputs, and this is because of rhizobium, and we'll talk about this more later. Also, reduced weeds because of increased competition. Have you ever noticed that other weeds don't grow with the clover? Generally clover, it crowds them out or does something to prevent other weeds, but also increased drought tolerance. Each of these add up to reduced costs. One additional component is the potential for a value-added product. Homeowners looking for a more sustainable approach, they don't mind a little bit of clover in their lawn. And so this integration provides the fertilization that the home lawn is going to need, while at the same time saving money. Rhizobium is a bacteria that has a symbiotic relationship with the legume family. It is not well understood how it works, but its existence is well documented. The rhizobium forms nodules on the roots of the legume. The rhizobium bacteria takes nitrogen from the atmosphere and makes it available to the plant. Some forms of nitrogen molecules are volatile, making them difficult to measure. But in this case, the volatility allows it to be accessed by other roots that are in proximity. American Indians were well aware of this relationship. The 3 sisters were a cluster of corn, beans, and squash they would plant together. The beans would provide the nitrogen for the corn and squash, while corn would provide a trellis for the beans to grow on. They would each grow and thrive in a different soil and canopy horizon. Nitrogen is a key component of greening turf. You can see with these pictures of the microclover plots the direct contrast between the very bright green squares of turf and the aisleways. The green plots definitely stand out pretty dramatically. Near the top of the photo are 2 areas, or several areas, that are brownish and green in color, but those are untreated. So you can see the definite contrast or impact of microclover. We have known for a long time that a healthier lawn outcompetes and suppresses weeds. If you ever looked at a clump of clover, you rarely see any dandelions or crabgrass or any other weeds. We're not completely sure at this time, but it's most likely because of the healthy stand of grass. But it could also be because of alleliopathic chemicals. It's very difficult to differentiate the two. You can see in the image the clear delineation between the with clover and without clover stands. Some research suggests that microclover can increase drought tolerance. We have constructed a rainout shelter to answer these questions. With increasing water scarcity or other issues on the rise, drought tolerance will continue to rise as an important issue for homeowners along with sod producers. We see a high potential for reducing costs at sod farms and from reducing inputs and labor. It's critical that any change to a sod producer's practices is minimized. The closer it is to their existing practice, the easier it is for them to adopt these practices. This is a critical component of the research that we're doing, that we try to mimic as best as we can those practices. Other areas where this might reduce costs or benefit organizations include parks and recreation. This could include campgrounds as well as parks, neighborhood parks, green belts, just grassy areas. Cities and municipalities also have an interest that they want to present themselves as well manicured or well maintained. Microclover can reduce their fertilizer costs that still maintain nice areas. Freeways and highways, also homeowners, and homeowners have been the largest target of microclover companies to adopt their product. Here is a list of our current collaborators. We're always looking to add to our list. If you're interested in supporting or participating, please contact Dave Gardner or John Street, professors of weed science and turf fertility at The Ohio State University. Their contact information will be shown on the next slide. We can always use help with research areas at other sod farms where we can grow out a quarter acre or a full acre of sod along with microclover. Or we could use help with the economic modeling, where we'll need to be able to access some of your financials, such as fertilizer, pesticide, and labor costs. And of course, we do this confidentially. But this would allow us to build an economic model to contrast the use of microclover against conventional methods. Thank you. Please watch our next video, which we go over the research methods and the research studies. Please watch our next video where we go over our results from our first year's research. We'll talk about the program setup or the research setup, along with what data we're measuring and the outcomes of our research.